Welcome to ArtSciTech. This is the intersection of art, science, and technology, a world that both inspires awe and provokes deep thought. Today, we're diving into one of modern science's most fascinating and controversial topics: cloning. Cloning is not just a scientific endeavor, it's a technological triumph that raises artistic and philosophical questions. What is life? What does it mean to replicate ourselves? These questions have preoccupied artists, philosophers, and scientists for centuries. From the birth of Dolly the sheep in 1996 to revolutionary gene-editing tools like CRISPR, cloning has transitioned from science fiction to reality. But how close are we to human cloning? Is it possible? Is it ethical? And how might cloning shape the future of humanity? In this video, we'll explore the history, current state, ethical dimensions, and future possibilities of cloning. If you're ready, let's journey into a world where meeting our genetic twins might just be possible. The story of cloning stretches back to the mid-20th century, with efforts to produce genetically identical organisms. But it was the birth of Dolly in 1996 that brought cloning to the global stage. Created at the Roslin Institute in Scotland, Dolly was the first mammal cloned from an adult cell using somatic cell nuclear transfer, SCNT. Her birth proved that complex organisms could indeed be cloned, sparking both hope and fear as it opened the door to human cloning. Cloning technology advanced rapidly after Dolly. In 2001, the first cloned cat, Copycat, was born, followed by the first cloned dog, Snuppy, in 2005. Efforts to preserve endangered species also began. Animals like the gaur and banteng were cloned. In 2018, the cloning of macaque monkeys in China marked a significant step toward the technical feasibility of human cloning. But the true revolution came in 2012 with the discovery of CRISPR-Cas9. This gene-editing tool, which won Emmanuelle Charpentier and Jennifer Doudna a Nobel Prize, allows for precise DNA modifications. By 2025, CRISPR has made cloning more efficient and accessible, revolutionizing fields from medicine to agriculture. Yet these advancements continue to be shadowed by ethical and legal concerns. How close are we to cloning a human? This question ignites both scientific curiosity and ethical debate. Technically, human cloning appears possible using SCNT. The nucleus of a donor cell is inserted into an enucleated egg, and embryo development is triggered. While this has worked in animals, cloning humans is much more complex. Even in animals, cloning results in high failure rates, premature aging, and health issues. For instance, telomere shortening can affect a clone's lifespan. In 2013, researchers at Oregon Health and Science University successfully cloned human embryos for research purposes, though not for reproduction. As of 2025, reproductive human cloning remains globally banned, and the scientific community holds serious safety concerns. Therapeutic cloning, such as generating cells for organ transplants, is less controversial and continues in limited research settings. In theory, human cloning is possible, but practically it remains distant due to technical and ethical barriers. Cloning is a method of producing genetically identical organisms, and it has been proven possible in animals. SCNT is the most common technique. A donor nucleus is transferred into an egg cell whose nucleus has been removed, and the cell is stimulated to form an embryo. However, this process is not as simple as it sounds. Success rates are low. Dolly, for example, took hundreds of attempts. Cloned animals frequently show epigenetic issues, problems related to how genes are expressed. Gene-editing tools like CRISPR have made cloning more precise. As of 2025, CRISPR is used to correct genetic diseases or add desired traits, but its use in human cloning remains risky. So is cloning possible? Yes, for animals, it's proven. For humans, technically yes, but the risks and ethical challenges have kept it unrealized. The ethical dimension of cloning is even more complex than the science. Opponents argue that cloning interferes with the natural order and equates to playing God. Religious perspectives call for the protection of embryos from the moment of conception, while philosophers question the identity and autonomy of clones. Is a clone a unique individual or just a copy? On the other hand, the medical benefits of cloning are supported. Therapeutic cloning may help treat diseases like Parkinson's or Alzheimer's. Cloning for organ transplantation could eliminate immune rejection. There are also environmental benefits, like preserving endangered species. Ethicist Julian Savulescu argues that regulated cloning could benefit humanity, while Leon Kass warns of losing our humanity. In 2025, this debate remains unresolved. Cloning is a source of both hope and concern. Cloning isn't limited to copying humans or animals. It also fuels the dream of reviving extinct species. Harvard's George Church leads the woolly mammoth revival project, aiming to recreate the species by editing elephant DNA with mammoth traits. Other targets include the passenger pigeon and gastric brooding frog. These projects are theoretically possible with CRISPR. But the process is not without controversy. Ecologists warn that cloned species could disrupt modern ecosystems. For example, how would woolly mammoths survive in a habitat that no longer exists? And is a cloned creature truly the same as its ancestor, or just a genetic replica? Some see this as a chance to correct past mistakes. Others argue that resources should focus on protecting existing species. Science fiction is merging with reality, but it's a complex journey, both technically and ethically. The idea of reviving extinct species once belonged to science fiction novels, but in 2025, it's becoming reality. Cloning and genetic engineering have the potential to reverse extinction. But it's not just about copying DNA. Even if a cloned animal shares the original's genetic code, environmental and social factors can lead to different behavior. For instance, how would a cloned woolly mammoth adapt to today's ecosystems? These projects are also expensive and resource-intensive. Critics say the money should go toward preserving endangered species instead. Still, these technologies offer hope for restoring biodiversity and ecosystems. Science fiction is slowly turning into reality, but this journey requires careful planning. In April 2025, the biotech company Colossal Biosciences announced the world's first de-extinction success, the return of the dire wolf, Enochion. This large wolf species, extinct for about 10,000 years, was popularized by the series Game of Thrones. Using CRISPR technology, the company edited 20 genes in gray wolf cells and created embryos, which were implanted into surrogate dog mothers. 3 pups were born, 2 males, Romulus and Remus, and 1 female, Khaleesi. With their white fur, the pups closely resemble the dire wolves from the series. However, the achievement sparked debate. Some scientists argue that these are not true dire wolves, but genetically modified gray wolves. For example, Duke University's Stuart Pym called the project a colossal fabrication and labeled the pups designer dogs. The genetic difference between dire wolves and gray wolves is compared to the difference between humans and chimpanzees. As such, some question whether just a few added genes can truly recreate a dire wolf. Cloning and genetic engineering give us the power to reshape human evolution. With CRISPR, we can potentially eliminate inherited diseases like cystic fibrosis or sickle cell anemia. But the technology goes further. Enhancing intelligence, physical strength, or lifespan may also be possible. The concept of designer babies raises the prospect of genetically customized individuals, but it also raises questions of equality and consent. Will a divide emerge between genetically enhanced and natural individuals? Risks like genetic diversity loss or off-target mutations are real. In 2025, genetic engineering is advancing in everything from medical treatments to agricultural innovations. Humanity is becoming the architect of its own biology, but this power must be matched with ethics and responsibility. Hacking the genetic code defines the future of cloning and genetic engineering. In 2025, CRISPR and other tools are used in areas like tissue generation for organ transplants, climate-resilient crops, and even the creation of new organisms. For example, microorganisms are being engineered to produce biofuels or clean up pollution. But these technologies require careful management. The long-term effects of genetic modifications are unknown, and the risk of misuse is ever present. Cloning pushes the boundaries of humanity, but this journey must not ignore ethics, equality, and environmental impact. Imagine one day looking in the mirror and seeing your own clone. Your clone would be your genetic twin, but not share your memories, experiences, or personality. This reopens the classic nature versus nurture debate. Meeting a clone would be like meeting an identical twin, genetically the same, but shaped by different life experiences. Clones could be used for organ generation or genetic backup, but their social integration, rights, and psychological impacts are major questions. For example, how would a clone build their identity? These scenarios show that cloning is not just a scientific issue, but a deeply human one. Cloning and genetic engineering redefine humanity's relationship with nature. In the future, will life be shaped in laboratories, or will nature's laws prevail? Cloning promises to cure diseases, save species, and even offer immortality. But it also carries risks of homogenization, loss of genetic diversity, and ethical violations. As of 2025, these questions remain unanswered. Cloning is both a source of hope and uncertainty. As humanity moves forward in this brave new world, it must do so with compassion, equality, and respect for nature. Our future will be shaped not just by scientific capability, but by our values. Cloning is more than a scientific curiosity. It's a mirror reflecting our hopes, fears, and dreams. It makes us question the boundaries of life, the ethics of creation, and the essence of identity. We envision a world free of disease, filled with revived species, and humans transcending biological limits. But this power comes with the danger of unchecked ambition and unknown risks. Thank you for joining us on this cloning journey here at ArtSciTech. Keep questioning, stay curious, and never lose your sense of wonder at the miracles of the universe.